Little circle trig. So could you take out a blank notability doc? And I just want to make sure that you can do basic circle trig because it's for sure on the final. And do you remember me saying that in almost every chapter after that, there was more stuff about circle trig? It kept coming back to circle trig. So let's just try a relatively simple one. Tangent of some angle is equal to 1. Now, the first thought I hope you have is usually there's two numbers over there, like a fraction. Okay, so you can make 1 into two numbers. Then, hopefully you'll figure out what quadrants you can draw a triangle in. Then, figure out what those angles must be. Once you're done with that one, try this one, and it's different because, actually, let's do cosine, because you can't draw a triangle for it. Cosine of theta equals 0. Think about it. There's no way to draw a triangle with sides of 0. So that one's got to be somewhere else. All right, I'm going to pause for a minute while you guys try this. Both of these concepts are for sure on your final, not wasting your time. So let's get some different people to chip in on this one. Let's use the Destiny. Row 1. This one would be Joe Tadros. Tell me how to do tangent of theta equals 1.
So tangent theta over 1 is just pi over 4.
You got to give me a little more than that. So where'd you get it from?
So I know it's not equal to 2 or 4.
Okay, why not? Why can't it be in 2 or 4?
Tangent's negative.
This tangent would be negative in those spots. Okay, tangent's positive in A and T, which is quadrant 1 and quadrant 3. And then, where'd you draw it?
I drew an A.
Okay, so if I draw it in A, then how do you put your little sides on it?
I forgot.
Oh, so tangent is TOA, is opposite over adjacent, so
So it'd be 1 over
1 and 1, and this is root 2, and then you probably by now know what type of triangle this is, and therefore the answer, you gave me only one answer though, that was disturbing. Isn't there two answers?
Yeah, it should be
Pi over 4,
5 pi over 4.
and awesome. I like to count it up, 1, 2, 3, 4, 4 pi over 4, and then for this triangle, one more of those, 5 pi over 4. So those are your two answers, pi over 4 and 5 pi over 4. What if this had been an inverse tan question? Just a little sidebar there. What if this had been tangent inverse of 1, and that would have been rewritten like this, but Teddy?
I don't think it'd be equal to 3, it'd just be equal to 1.
Yeah. There's only going to be one answer, and inverse tan is only allowed in here, and therefore it would have to have been the pi over 4 answer. Okay, so that's if we had changed it to inverse tan. How about the cosine of theta equals 0 question? Completely different. Selena, tell me how you did that one.
I labeled the points.
I like it. 1, 0, 0, 1. -1, 0, and 0, -1. Okay, now what?
And then since cosine is x, the 2 points where cosine is 0, or where x is 0, are at pi over 2 and pi over 2.
So since you're looking for cosine is x, she said, you're looking for the spots where x is 0, and those are the two spots. And therefore, there's two answers. What's this one?
Pi over 2.
Pi over 2, and what's this one?
Pi over 2.
3 pi over 2. Good. How come I didn't say negative pi over 2? When would you ever have said negative pi over 2 for this? There is a time. Doge. If we was an inverse trig question, then this would be the negative zone, and you wouldn't have had two answers. You're right. You would only have had one answer, and it would have been negative pi over 2. Okay, so that's if this had been an inverse trig question. All right. How could it have been an inverse trig question? Well, if it would have said cosine with a little -1, inverse cosine of 0, then you would have rewritten it like this, but it would have had restrictions. And let me think though. Inverse cosine's only allowed up here. Whoa, that's blowing my mind. Okay, so then I couldn't have said this answer because inverse cosine's only allowed up there. So that one would have been just pi over 2 if it had been an inverse trig question. Now, can you get inverse trig answers that are down there? Yeah, but not cosine. Inverse cosine's not down there. All right, so there is some there was some circle trig. Let's do one more circle trig question. This, again, is on the final, and I know it's super important, and I know it's also often on the ACT. Let's do, if sine of this angle is -√3 over 2, and tangent of the angle is less than 0, aka tangent of it would be negative. Now you can know what quadrant you're in, and you can draw the triangle, and like I've always said, draw the triangle, get all of its sides, and if you can, get its angles, and then you could probably answer the question. The question is, what's theta? I'll pause for a second when we try that one. Tell me, what did you start with when you started this problem?
I tried to find what quadrant the triangle with theta was in.
Okay.
I thought since it was negative, it would be in the first or the second quadrant.
You got it, so it had to be in one of those two. Then tangent was negative. What did that tell you?
That it probably wasn't in the third quadrant.
Excellent. So then, if you haven't already, everybody, draw your triangle right in there. Then, if I'd like to talk about something else we haven't talked about very much, what if the question hadn't been theta? I know you guys have probably already answered that. What if the question had been, what is secant of theta? Dredge that all up from your memory banks. I'll pause for a second. Let me figure that out. So, let's finish this one off. Sine is opposite over hypotenuse. And then what's across from the √3? Well, not the 30. The 1 is across from the 30. So the √3, that's the 60. So this is a 60-degree angle, but it's pi over 3. But do I want to do negative pi over 3? No, because it's not inverse trig. So it's just a bunch of pi over 3s. 3 pi over 3, 4, 5 pi over 3. Remember, always stop here for 3 pi over 3 to kind of get yourself set to, oh yeah, they're 1/3 of the way. All right, so then 5 pi over 3 was your answer for this, right? Okay, then secant of it. Well, to get secant, I told you guys I wouldn't do secant. I would go do one I know that's the sister of it. And I instead would go do cosine of it. But I'd try to remember that I'm flipping it by going 1 over cosine. So I'm going to go get my cosine, but I got to remember to flip it. Cosine is adjacent over hypotenuse, which is 1/2. But then you flip it, and you get 2. How many of you had 2 for your secant? Okay, good. So there's a good review of circle trig. It's for sure on the test in multiple places. And if you need more help on that, please ask. Yes?
How do you know when to use positive and negative angles for theta?
Okay. The only time you would want to use negative angles for theta that I can think of right now would be inverse trig. Okay? So if you're doing an inverse trig question and your answer ends up forcing you to draw it down here in this quadrant, just remember you're in the negative zone. Okay? So how would you ever be down there if you were doing an inverse trig question? In fact, I'd like you to figure that out. Give me some function of something. Give me an inverse trig question that would force you to be down here. Remember, this is an inverse trig question. So it's got to be sine, cosine, or tangent of something that would force you down into that quadrant. That's a question we could have asked. In fact, I might ask that on a future final. Give me a problem that would force me into the negative zone. I'm gonna pause for a second while everybody tries to figure one out. Down there. Inverse tan of what? Gotta put something in there. See, you can't tell me an angle right now. You gotta tell me some sides. So what sides would force you down in there? Yeah, 1 over negative 1 would absolutely force you down there. I like that. Now, one person could argue and say, wouldn't that just be negative 1? Yeah, true, but I like it when you give me two sides anyways. So his works, his forces me down there because do you get inverse tangents only allowed from here to here? And if it's negative, I can't be here. So cool. Now, TOA, opposite over adjacent, opposite side is technically the one that's going to be negative, but that negative can move up there easy, right? Over adjacent side will be 1, and then this will be square root of 2, and then that answer would be 45 degrees, aka pi over 4, but it's negative pi over 4 because we're doing inverse trig. Okay, so that's an situation where you'd have a negative angle answer. Okay, otherwise, if you're doing a regular circle trig question like this, tangent of some angle equals negative 1, you would not give me a negative answer. Only if you're doing inverse trig. Okay, that was a good question. So, anything else off the packet? I've given a chance to ask before, so I wouldn't be terribly surprised if there weren't many questions, but I'd be willing, if you found one that you're still like, this is going to get me on the final. Grab your packet. You're not turning it in today. You're turning it on the day of the final because I'd like you to study from it still, but are there any topics in there off of your packet you'd like a little help on? Kira.
Number
18.
18.
Everybody look at 18 for a second. All right. Fundamentally, that's cotangent because it's cotangent. Here, for those at home, number 18 looks like this. It is y equals negative cotangent of x minus 1. Would you agree that this part right here is going to flip it over? Whatever the graph is, it's going to flip it. Does that make sense to you? Okay. And do you agree that this is going to take whatever the graph is and it's going to move it all down 1? That makes sense? No matter what it was, it's just going to move it all down 1. So then what is cotangent? You need to memorize these. I will happily graph all of the basic functions for you right now. You should sketch them in the margins. I don't know if you'll have enough room. It's your call, but sketch them somewhere. Back side of the packet. Is there a blank page back there? Nope. But find some place where you can sketch each of them. Here is cotangent, one of the more obscure ones. It goes from 0 to pi, and it goes like that. That's what cotangent looks like. And then, like I said before, that's just going to make it vertically flip, and that's going to make it move down 1. I think vertically flipping it isn't too bad, I hope. What was up goes down, and what was down goes back up. Okay, so it's the red one now. And then the whole red graph would move down 1. Every one of these dots here, you could just move it down 1. All right, so that's cotangent. Let's do the others. Here's tangent. If you haven't already sketched tangent for yourself, that's what tangent looks like, and it goes between pi over 2 and negative pi over 2. Any questions about that one? Yes?
Why does that negative pi over 2 to pi over 2?
Because that's what's to the left of the origin. Like, if this is the origin right here, right? We can't have positive numbers over there to the left, right? Okay, so, and it has to go the same distance here. So if we know that one's pi over 2, we can know the other one's negative pi over 2. And I could give you a much longer answer, but I'm trying to get through all the graphs. All right, next up is sine. That one's probably one of the best memorized ones. Starts at 0, 0 and does this. Got to remember it ends at 2 pi. I like to go halfway and halfway. And then figure out what I'm counting by. 1 pi over 2, 2 pi over 2, 3 pi over 2. And I like to think of this as 4 pi over 2. Yes, it's the same as 2 pi. It goes up to 1 and down to -1. Cosine, I will do on the same graph, but I'll do it in blue. I like to do it in 4 parts. 1 part, 2 part, it hits the bottom. 3rd part, 4th part, it's back up. It's like a valley. That's cosine. That's sine, cosine, tangent, cotangent. What's left? Secant and cosecant. So to graph secant, you graph cosine, but then you have to also put in wherever cosine hits 0, you have asymptotes. And then secant is the graph that goes like that. That is certainly not perfect, but that's the rough sketch of secant. It rides on the back of its sister function, which is cosine. Questions about that one? Okay, and then last is cosecant. What do you think I'm going to graph first on cosecant? Say it. Sine. There's sine. And then wherever that hits 0, remember the cosecant is the flip of it. It's 1 over that. 1 over 0 won't exist. Then cosecant rides on the back of its sister function. And there's cosecant. You guys have asked very good questions today. So good that I'm going to write them down. Any other topics from the packet that you want to talk about? Yes?
Number 22 and the first, third, and fourth one.
Number 22. Within number 22, the what?
The first, third, and fourth, they're actually all of them.
Okay. I'm going to just start, and it says inverse sine of tangent of pi over 4. Okay. Anytime you get a scary math problem, always start one step at a time. You just have to do one thing, okay? And where do you think we should start? On the inside or the outside? Inside. So we start in there. So can you just, whenever you have trig, I would draw it. Can you tell me where tangent of pi over 4 would be? Well, is there more than 1 pi over 4? Sometimes people get confused, like, isn't there 2 places? No, pi over 4 is only one spot. Pi over 4 is here. That's where pi over 4 is. So then I can draw a triangle around that and go, okay, so if it's pi over 4, that's the same as 45, and so it's a 1, 1, and a square root of 2. Okay, then I go tangent of it, TOA, opposite over adjacent. Opposite over adjacent. Oh, so tangent of that is 1 over 1. So I'm done with this problem, and it is just 1, or I could say 1 over 1. Now, relook at your problem. Do you get that it's an inverse sine question? All right. So inverse sine now has different rules. You remember that? It's like sine of some angle equals 1, but, and it's a big but, it can only be over here. So these are out and this is out. And now sine's positive, so then this is out. So then it has to be here. See how it's a whole bunch of little logical leaps, like, well, can't be here, has to be there. Do you get why it has to be there? Okay. Then sine is opposite over hypotenuse, 1, and wait a minute, 1 and 1. So then I go, this can't be a normal triangle. So now I'm left with it's either here or it's there, because those are the only places that qualified anymore. We threw out everything else. And what is sine? Is it x or y? Sine is y. So y is 1, really. So if y is 1, I look for which of these has y as 1. That one does. So what's the answer? pi over 2. So all the other ones, you start on the inside, you find the triangle, you draw the triangle, you figure out all the sides, all the angles, and then go to the outside and restart the problem again. Okay? I'm willing to do more of those, but I just want other people to ask me. I just don't want to do 3 questions in a row for one kid. So you can always ask me individually, if you want me to do that later. Okay. Any other last questions? Yes. Number 5. Oh, 25. Everybody look at 25, please. Okay. It says 2 cosine squared of x minus root 3 cosine of x equals 0. Well, anytime something's equal to 0, I think to myself, can I factor it? Because if you can factor it, you should. Now, this wouldn't factor the normal way, but do you get they both have a cosine in them? And you can factor that cosine out. Now, I've got cosine, and I factored it out, and I got to see what I have left. There's a 2 left for sure, right? And then cosine times, I'll need another cosine, because the way I like to think of it is this times this has to make 2 cosine squared. So there. Minus square root of 3, and I just check, and does this times this give me the other part? And it does. Cool. Then you've got 2 problems then, Jack. Cosine of theta, or so cosine of x, or theta, doesn't matter, equals 0. And that seems like it's not going to be drawing a triangle, right? Because it's got a side of 0, so then that's one of the quadrantals. And there can be 2 answers for those. So you draw it, you figure out where x is 0, and get a couple answers. And then this one, 2 cosine x minus root 3 equals 0. I'm going to add root 3 to both sides. That puts that over here. Okay, adding root 3 to both sides. Then I'm going to divide both sides by 2. Oh, and it's another circle trig question. Is it an inverse trig? No. So then there are probably 2 answers for it. Okay. Now, I know it's a lot, but this is all problems that you've had in the past. There is nothing new here. You've been tested on all of these things, and you passed those tests. Okay, I probably, maybe there's an exception of 1 or 2 kids that didn't pass one of these tests, but you passed them, or you took a retake and you probably passed it, and most you got A's or B's on them. Now, I know you may have, it's been a while, but we've had several days to review it, and you still have more time. You have tonight, at a minimum, to review it. Okay, so last thought on this is, I know in most of your classes, if you get 75% of the problems right, you get a C. Don't forget, this is Marzano graded test. Okay, so that means if it is harder than a normal test, but a 75% on both parts of the test gets you a straight A. Okay, 95%. That's higher than the 92.5 average that you would need for an A in this class. So you will get a 95% if you can just get 75% on both sections. If either one of your sections is below 75, of course, your grade will be lower than an A. But you could probably, all of you could probably count on getting half right. Just half. Half right in the easies and half rights in the hards. If you get half right in both, you'll have a C. I know a lot of people wouldn't be too thrilled with a C, but the C isn't going to probably lower. Many of your grades wouldn't be lowered by a C. So if a half right is kind of the floor, you should get at least half of them right. Then most of you won't lower your grade with the final. Now, there are some people where a C would lower your grade. Well, then make sure you get better than half. Hopefully you'll get 3/4 of them right in both sections and get a straight A. Yes?
How many questions are we?
That doesn't really matter. The final is similar size to this, a little shorter. Okay, so think of it as it's a little shorter than this peer review packet that you have in front of you. Yes?
Is it weighted like this one is a unit test?
It is weighted like a unit test, yes. So it's like a regular test factored into your grid. Yes?
How much time will we have to complete it?
You have about 2 hours. So it's longer than a normal test, but you got a lot longer time. All right. So I know for some of you, you're going to look at a few of these problems and go, "Pfft, I won't be able to do that." Well, you could fix that right now, or, coming up and asking me for help or studying it tonight. And I did make a review videos like the one I'm doing right this second. And you could go watch those and see if it's in there. There's a key for it. You probably might have some friends you could call and ask for help. So don't give up on problems unless it's one that you've been banging your head against since like the first time. You never got that type of question. Well, then you may want to let that one go. You get that you could probably have a good 5 questions on this thing that you didn't know how to do and you might still get an A. Okay, so a lot of you think that, oh my gosh, there's 3 things I don't know going into the final. You can still get an A. For sure, with 3 things, you can still get an A, absolutely. You just have to get the other ones right. And there's nothing I can really say to make the fact that you have a test. It's pressure, I know, it's pressure. You have a test, I can't make that better. But know that you've done these before, and you already have passed this test. You just have to pass it again. All right, that's all I got for the video for today. And